grade 11. I am Miss Asma. Now we are beginning the final revision about your chemistry. We will focus on the main points in your module, so we will begin with chapter 1. Chapter 1 was talk about atomic structure. We have many scientists who interested with atomic structure and what is the atom, what's the structure of atom, and atomic theory. So we have Boyle, Aristotle, Democritus, and Rutherford, Thomson, Bohr. Okay, about Democritus, he imagined that we can divide any piece of matter to smaller parts, and until we reach to indivisible substance that's called the atom. And Aristotle refused this concept, so he saw that any substance consists of four main components: that water, air, dust, and fire. So we can convert by any matter and another matter by change the distance or change the percentage of any of these materials. So we can change any cheap material, any precious one. And the Boyle idea, he rejected Aristotle's idea, that's silly idea for sure, about the nature of matter, and gave the first definition for the element. He said that the element is a pure substance that can't be changed to simpler form by the traditional chemical methods. So we have atoms and we have compounds, we have molecules. So he gave example about the molecule NaCl, and example for compound NaCl, and example for molecule Cl2. It's chlorine molecule. About Dalton model, he was the first scientist that had a theory about atomic structure. Number one, element is composed of very minute particles named atoms. So he was the first one. He gave a definition about the atom. Atom is a very minute indivisible solid particles. Mass of atoms of the same element are similar, but they differ from element to another. So we have oxygen atom and we have nitrogen atom. Each one of them don't have the same structure or the same number of protons, number of electrons. So they are different from each other. And number four, components are formed by combination of atoms of different material in similar numerical ratio. So if we have any compound like NaCl, sodium chlorine, so we need one atom of sodium and one atom of chlorine. It's simple ratio. There is a definition, an important definition about isotopes. What the meaning of isotopes? They are different forms of atoms, but have the same atomic number, but different in mass number. So they are different in number of neutrons. We focus on that. We have important definition about the isotopes. The isotopes, they are different forms of atoms of the same element, So we have two different shapes of the same element, like H, for example, hydrogen. But isotopes different in are the same of atomic number, but different in mass number. So they have the same number of protons, same number of electrons. They are the same thing, by the way, but they different in number of protons. We focus on that. Number 5, Thomson's model. Okay, he was the first scientific model about the atom. Okay, he gave an information about cathode ray. It's a stream of invisible rays with emitted from cathode cause fluorescent glow of the tube wall. Okay, how he gave that? He has a solid sphere. Okay, and he imagined that the atom consists of electrons, consists of a sphere, its nucleus. Okay, and consists of many small particles of electrons. Okay, so he imagined that his atom consists of, and the sixth scientist who's Rutherford model. Okay, Rutherford has some postulates about his theory. He has atom, nucleus, and electrons. Okay, how he did that? He used that NS. Okay, is used to detect invisible alpha particles as they glow at the position where they collide with the substance. Okay, this is the example of model of Rutherford. Okay, Thomson model is different about Rutherford model. Okay, how they are different from each other. Rutherford used alpha ray to detect his model of atom. He concludes that neutrons, they are not deflected, contain a straight line as they are, but protons, because it have neutral charge, as we know, protons, they are deflected toward the negative electrode as they are, but electrons, because it have negative charge, it's opposite of positive charge, which belongs to alpha ray, they are deflected toward the positive electrodes, which is alpha. Okay, is the model of it. Okay, we have the atomic emission spectrum on heating atoms of pure elements in gases or vapor state to high temperature and low pressure. Okay, we focus about that conditions we should do, heating them in high temperature and low pressure. Okay, why? To get a line spectrum belongs to the atom. It was found that it's composed of limited number of circle colored lines separated by darkened area. Okay, we have example on it. These are example of line spectrum about hydrogen. It consists of 4 colored line. Okay, so about Bohr's postulates, he agree with Rutherford postulates, made a new postulates. Okay, so postulate number 1 about Bohr, he said that an atom, in a stable atom, it's don't begin to lose or gaining any of energy. Okay, but it consists of 7 main energy levels. Okay, but it cannot be found in regions between these levels. So we cannot to find electron in the region between K, L, M. Okay, we can find electrons in K energy level, L energy level, M energy level, but we cannot found it in regions between them. So the electron move from energy level to another energy level, or bare electron jumping, a complete jumping from one energy level to another. Each electron in the atom has definite amount of energy, because of that it's called energy level, because it has own amount of energy, depends on the distance between the energy and nucleus. Okay, this graph indicate a spectrum line belongs to hydrogen. Okay, be focused that any of a hydrogen consists of 1 electron, as we know. So all of electrons that gain some energy, it's called excited atom. So it take a half time, it's called half time, that's take the electron that electron took to move from higher energy level to lower one. Okay, so he return back to the second energy level, so he can ask you about the energy level that's line spectrum of hydrogen belongs to, and be focused about energy and wavelengths, they have inverse relation, and energy of frequency, they have direct relation. So it be focused by electrons, but wavelengths and frequency, they have inverse relation. Okay, be focused of that, that's main point about it. Okay, we have some definitions, some important definition. The quantum, it's equal amount of energy gained or lost by an electron jump from one energy level to another. So the electron, as we said about Bohr, electron absorbs some energy to move out. It's sufficient to move from one energy level to another. It's called amount of energy. But electron that's gain some energy, this atom called excited atom. Okay, electron doesn't move from its level to another unless the energy absorbed or emitted is equal, must be equal to difference between 2 energy levels. It's called one quantum. That's sufficient to move them from one energy level to another energy level. Advantages of Bohr's atomic model: explain hydrogen atom spectrum very clearly. He introduced the idea of quantum. He's the first one who introduced that. No to detect the energy of electrons and energy level. Okay, he don't help us to know the energy of electrons, and he proved that electron during rotation around the nucleus in ground state don't radiate any energy, so they will not fall back to the nucleus. And we have some modifications about Bohr's model. Okay, so we have principal modern atomic theory. The principal modern atomic theory is classified into 3 main points. Number 1, dual nature of electron, and Heisenberg uncertainty principle, and wave mechanical theory of atom. About dual nature of electron, that electron has its material particles and wave particles, so it has two two nature, not one, as Bohr said. Bohr is neglect that electron has wave property. About Heisenberg uncertainty principle, Bohr postulates that we can determine the position and velocity of electron at any time at any place, but it's refused by Heisenberg. It's practically impossible to determine both position and velocity of the electron. Okay, and wave mechanical theory of the atom, Schrödinger showed by wave equation that apply to the electrons that you study in physics, by the way. Number one, it's possible to determine the allowed energy level of the electron. Number two, define regions, space around the nucleus where it's most probable to find electron in each energy level. Okay, we have two main definitions, important definitions. We have number one, electron cloud, area of space around the nucleus where they are in great probability to finding electrons in all direction and all positions. That area is Z. And we have some definition, and another definition is orbital regions inside the electrons cloud in which what possibility of presence of electron increase. So he can give you this example in your exam as these electron clouds, and we have a great probability to find the electrons, but the possibility to presence electron increase in this area, which is called orbitals, and we will know about orbitals clearly in chapter 2. So we will transfer to the quantum number. We have four main quantum numbers. Number one, principal quantum number, which is symbol is N. Okay, principal quantum number is the main 7 energy levels. Okay, so we have 7 energy levels. It's named by from K to Q. Okay, K, L, M, N, B, and till Q. Okay, the rule 2n square isn't applied to energy level higher than 4, so we can apply it from K, L, M, N. Okay, after n we can't apply this rule to n square. Okay, n is the first energy level, second, third, so it's equal 1, 2, 3, or 4. Number 2, subsidiary quantum number, which takes the symbol L square. Okay, describe the shape of electron clouds in the sublevel. We know that each main energy level consists of energy sublevels. Okay, and he take the rule 2L plus 1. We have 4 subsidiary quantum number S, P, D, F, and take the values from 0 until n-1. So S has value 0, and P 1, D 2, and F 3. So we cannot find any subsidiary quantum number more than 3 if its value more than 3. Okay, number 3, magnetic quantum number M. I take the symbol M, L small. It describes the shape and number of orbitals in which electron exists. So if we talk about S consists of one orbital, so this one orbital will take the value 0, but P has 3 orbitals, so it will take the value from 0, positive 1 in these orbitals, and negative 1 in another way of the orbital. Okay, and we have D in the middle orbital. In the middle orbital, we will begin to take it. Give it the value 0 and complete them by positive 1, positive 2, and the other side we have negative 1 and negative 2. Okay, number 4, spin quantum number ms. It describes the spin of motion. As we know, motion of electron. As we know, electron has negative charge. So if we have 2 electrons in the same orbital, it has repulsion force between as negative charge with negative charge. But in the atom model, we have 2 electrons in the same orbital. So one of them is moved in clockwise direction, and another electron will move in anti-clockwise. So one of them take the value positive half, and the other electron take the value negative half. So the positive half is the first electron in the orbital. Okay, and the second orbital will be negative half. The second electron in the same orbital will be negative half. Okay, principle of distribution of electron. Okay, we talked about last years as we took the electronic configuration about main energy level, only main energy level, but we have another way to distribute electron or configure electrons. We have 3 main rules. Pauli exclusion principle and building up principle, Horn's rule. Okay, about Pauli, he said that no two electrons can have the same set of quantum number, so it's correct. Now we will begin the incorrect orbitals. Okay, it's correct. This orbital of 1s is correct, but the another electron has n equal the first quantum number n equal 2 and L equal 0 about S, okay, and magnetic quantum number equal 0, but about spin quantum number all of two electrons have positive halves, so it's incorrect. And another orbital all of them have negative half, so it's incorrect. But the correct way to distribute electron about Pauli exclusion is about this way. And the second rule is building up principle. Okay, we have, as we said, an energy levels. Each energy level has its own amount of energy, so we cannot do building up principle or principal energy level has higher energy before filling the lower one, so we cannot begin by to the second energy level until completely filled, or make the first principal quantum number is completely filled. So we will begin with 1s, 2s, 2p, 3s, 3p, and spdf is the right arrangement about amount of energy. So S is the lowest energy and F is highest energy. مش هحسبك شوية. 3. Horn's rule. No electrons bearing take place in given sublevels until each orbital contains one electron. So in p block elements, in p sublevel, we have 3 orbitals. So we can fill 1, 2, 3, and we will return back to fill another electron in the orbital in this way, and the second and the third. So the all of electrons in p will be equal in the final equal 6 electrons. And in another hand, 1s, 2s, 2p. Okay, we cannot to begin to fill 2p until we completely fill 2s. So it's wrong. Why? Because this electron is correct place in this orbital, because this orbital is empty and the orbital before it completely filled, and it's wrong. So we have to fill this electron by this way, 1, 2, 3, and we will return back to fill these electrons, and we will complete by the second electrons and so on. Okay. And we have another simplified way to electronic configuration by closest or nearest noble gas. Okay, in zero group we have noble gas, which is by arrangement He, helium, neon, argon, krypton, xenon, radon. Okay, we can begin with helium. Okay, like any atom consists of atomic number equal 4 electrons, so we can electron configure it by, we will begin with He. So we take 2 electrons from the rest of 4 electrons, and we will complete it by 2s, and that's it. Okay, and we complete by this way. There is exception cases about electronic configuration in chromium, Cu, Mo, Ag, Au. These all of them are located in d block elements, and d block elements be stable or saturated by three ways. Or the first case is empty. All orbitals of d must be empty or completely filled or half filled. So in chromium, if we make electronic configuration, it will be R118 and 4s2 3d4, but we will move one electron from s until d, so it will be like that, 4s1 and 3d5. So it's stable, and we will make the same thing by Cu. Okay, we will make 3d is completely filled by 10 electrons, and 4s will have 1 electron. Now we will begin with chapter. We will complete our revision by chapter 2. Okay, chapter 2 begin with periodic table of the elements. Okay, all of elements are arrangement in these table. Okay, in this way by this table. Okay, we have four blocks in the table. We have four subsidiary quantum number, four sublevels, which are S, P, D, F, and the arrangement in this way in this table. Okay, so about S block element, it consists of, okay, at the first we have seven periods in the table and 18 groups. Okay, 7 periods as we have 7 main energy levels. Okay, the first, second, third, fourth, fifth, sixth, seventh, and we cannot say about this series by period, another period. No, it's series. Okay, because all of these series, it's part of D block elements, or not D block elements, F block elements, but it's located in this way. But to don't make the table it's very long and be suitable for the page, we can put it in the below of the table. Okay, and it's F block elements. Okay, about S block elements, it has two groups, 1A and 2A, and we could complete it completed by 3A and P block elements. It consists of P block elements is saturated with 6 electrons, so we have 6 groups in P block elements. Okay, 3A, 4A, 5A, 6A, 7A, and the 18, not 8A. Okay, it's called zero group, and there is a noble gas located in it. Okay, the first energy level saturated, the first main energy level saturated with 2 electrons, so it has only 2 elements in it. 1, 2, okay, 3, 4, 5, 6, 7. So atomic number increased in period by 1, but in group it increased by 7. Okay, because it's one energy level is completely filled. Okay, and we have S block elements and P block elements called representative element. Okay, about D block elements, it consists of 10 groups. Okay, but in 8 group we have 3 columns. Okay, because D block elements have 5 orbitals and is saturated with 10 electrons, so it has 10 groups. Okay, it has 10 columns. Okay, and 8 groups. Elements in the same group, similar in what? Similar in chemical properties. So he can give you some examples of electronic configuration or atomic numbers of some elements and ask it about you. And ask it about which of two elements have the same chemical properties. In this case, we search about 2 electrons have the same group or located in the same group. So elements in the same group are similar in chemical properties, electronic configuration of the last level, and indifferent about principal quantum number, because principal quantum number, it belongs to what? Belongs to same period, belongs to the same period. Okay, it's similar in what? Similar in principal quantum number n and in of this last energy level. Different in chemical properties because it belongs to the same group and electronic configuration of the last level. Okay, types of elements, as we said, the first is noble gas, is located in this group, it's called zero group. Okay, or 18. Okay, and representative element, it consists of 1A, 2A, 3A until 7A, which is called halogens. 7A, only 7A, only this group is called halogen, but S and P together is called representative element. Okay, number 3, D block elements called main transition elements, and the fourth one, it's it's F block elements is called inner transition elements. Okay, we have some details in D block elements. In the first transition series, D block elements consist of series. Okay, series in it. So we will begin with the first transition series, and it will be a close friend in the second year, by the way. The first transition series, it includes the elements in which 3D sublevels is filled successfully. Okay, it lie in the fourth period, include elements from scandium 21 and zinc 30. And the second transition element, it's so on, and it's include the elements in 4D and began with deuterium to cadmium, and the third one, it's 5D and from lanthanum to mercury. Okay, So lanthanum located in D block elements, not F block elements. Its main point. F block elements, they separated down and susceptible to avoid being too long as we said. In this block, F sublevel is filled successfully, okay, and it has 14 elements because F block elements has 7 orbitals and for 14 electrons, and it's completely filled by 14 elements, okay. About F block elements, we have two series. The first series called lanthanides, okay, and the second one called actinides. So about lanthanides, it began to fill 4F with 14 electrons. That's why to have 14 elements. And about actinides, it began to fill 5F and include 14 elements, okay. About determination of element location in the periodic table, we have representative element. It's located in block S and P, okay, but NS must be from 1 to 2 because S completely filled with 1 electron or 2 electrons, okay. But the group number, it's number of electrons in S, okay, in lowest sublevel, okay. So the group symbol will be A, 1A, 2A, 3A, okay. About P, it's NS2 and NP from 1 to 5, okay. Why we exception for 6? Because NP6 belongs to noble gas, so any electronic configuration ends with NP6, it belongs to 0 group, but from 1 to 5 it belongs to representative element. So to determine the group number, we can make the summation of these electrons in S and P, okay, to determine what group number, okay. And the period number, it's N. This N is called period number. So if N equals 3, so this element located in the third period, okay. And group what? Group of 2, and we can suppose that P has 3, so 3 plus 2 equal 5. This element located in 5A. About transition elements in D block elements, okay, electronic configuration must be began with S and N equal in N minus 1 or difference 1 in D. How? We have example for 4S and 3D. Be focused of that because sometimes he make electronic configuration and he exchange between them, and he in this example or in this case of questions, he ends his electronic configuration by S, okay. So you can imagine that's located in representative element, but it's wrong because before it has D, okay. But if we have two numbers there and N of S and D is N negative 1 or last one from S, it's located in D block elements, okay, not S or not B, okay. About group number, we make the summation of these electrons in S and D. So if the summation will be equal 3 to 7, it's located from 3P or 7. So if we make a summation from them and it's for example 3, it's located in 3P. If make a summation, it's equal 8 to 10, 8, 9, 10, it's located in 8 group because as we said, 8 group consists of 3 columns, 8, 9, 10. And if the summation equal 11, it's located in 1B. If the summation equal 12, it's located in 2B. The graduation properties of interperiodic table, okay. We have some properties and we will talk rapidly about each of them. Atomic radius, ionization potential or ionization energy, it's same thing. And electronic affinity, electronegativity, metallic and non-metallic, acidic and basic property. About radius, okay. Radius is increase in the same group and decrease in the same period from left to right, okay. But from right to left it increase, okay. But in this to take easy about you, we call that's increase in the group and decrease in the period because the period began from this, okay. Why? Because in the same group the main energy levels increase, and by increasing the main energy level, the distance from electron, the energy the distance between nucleus and the lowest energy level will be increased by increasing atomic number, so it's increased in the same group, but in the period we increase by electrons, so we have the same energy level, and the nuclear charge will attract it again, so the radius will be decreased. Okay, let's differentiate between ionization potential about excited atom and removed electron. Okay, if we have atom, okay, an electron, if we give this atom some amount of energy, but this energy is too small, so it will be excited atom. But if this energy is sufficient to make the electron get free or removed from this electron, so it's lost and changed into positive proton, it will be removed. So it depends on amount of energy that's gained by the electron, by the way. And the third property, electron affinity. Okay, electron affinity, gain an extra electron. It's opposite of ionization energy. It's gain some energy to get what? To get positive ion. Okay, but electron affinity, it's release some energy to change it into negative ion. Okay, but the magnitude of electron affinity is high when added to electron make the sublevels half filled or completely filled. Okay, the electron affinity value for beryllium, nitrogen, neon is close to 0. Electron affinity of chlorine is higher than that of fluorine, and it's a special case. So in this periodic table, we can imagine that electron affinity decrease in the same group and increase in the period. But if we take this rule in this group, so we will say that F is increased or higher in electron affinity than Cl, but it refused because it's special case for 7A and 6A, 5A. Okay, so Cl is much higher than if S is higher than O, and it's special cases, and he asked about it in your exam. Okay, number 4, electronegativity. What about electronegativity? It's the ability of atom to attract electrons toward it in the bond, okay, in the covalent bond. If you remember, we can share electrons by 2 bonds or by 2 non-metal bonds. Okay, so one of them has higher electronegativity and one of them has lower electronegativity. The higher one will attract the electron toward itself, okay, and we have partially negative like that, and another one will the electron will be very far from it, and it has partially positive. Okay, so we will move to metallic and non-metallic property. Okay, all of metals located in this way of these places in periodic table, okay, it has purple color, and non-metals has yellow color, and metalloids in green color. Okay, but metallic property, we have strongest metals in in group 1A. Okay, but metallic property must be decreased in the same period until we reach to metalloids, and non-metal will be increased. So metallic property and non-metallic property is refused from each other, it's opposite from each other. Okay, metalloids have the same properties of metal and non-metal. Okay, these examples of metalloids is very important. Metallic property decrease, okay, and non-metallic increase, as we said, and metallic property increase in the periodic table. So in the same group, so cesium is considered the most active metal, and fluorine is considered the most active non-metal. Okay, about acidic and basic property. Okay, we have simple way to make this. If we can say the first atom in the compound. Okay, if it's non-metal, so it's acidic oxide. If this is metal, so it's basic oxide. Okay, so carbon is sulfur in nitrogen, all of them are non-metal, so our oxide is acidic oxide. But if them is metal, so it's basic oxide. Okay, but basic oxides, we have some of them dissolve in water and don't dissolve in water. Okay, about acidic and basic property, they dissolve in H2O, water, to form alkaline solution, to react with acids to form salt and H2O. Okay, and we have another example of type of Oxides, we have amphoteric oxide, and it's very very important. But the example of it, Al. So Al is metal, okay, so it must be basic oxide, but it reacts with acid to form salt and water. It react again with alkali to form salt and H2O, so it's called amphoteric oxide. Not Al only, but Zn, Sn, and Sp. About the strengths of acid, so we will separate each of H by an oxygen, okay. We have 4 H atoms, okay. We will separate it by 4 oxygen atoms, okay. So we have 4 OH, and the hydroxide formula, which is OH, the ratio between N and M, okay. N is the number of oxygen atoms non-bonded with hydrogen. In this case, we haven't any oxygen non-bonded with hydrogen, but number, and M is the number of oxygen atoms bonded with hydrogen. So we have 4 oxygens, okay. And the strength of acids is measured by number of oxygen non-bonded with oxygen, okay. So we haven't any of them, so it's weak acid. But in this case, only 1 hydrogen will separated with only 1 oxygen, so we have 3 oxygens non-bonded with hydrogen, so it's the strongest acid. About oxidation number, it's in ionic compounds the number of electrons that's lost and give positive ion, okay, and number of electrons is gained and give negative ion. But in covalent compound we share electrons, so we haven't positive or negative ions. So it shifts the electron away from less electronegative electron atom and shift electrons toward to more electronegative ion. But we have rules in it. If the oxidation number of element atom in the molecules not gain or lose any of energy, it's in its molecular state or atomic state, so the oxidation number of it equal 0, okay. But if it's located in group 1A, it will be equal positive 1, 2A located its oxidation number equal positive 2, 3A equal 3 because it lose 1 electron, lose 2 electron, lose 3 electron, okay. But the oxidation number of fluorine in all of its components equal negative 1, okay. So if we need to calculate LiCl, okay, we need to calculate the oxidation number of Cl. So all of these compounds equal 0, and we have Li, it's located in group 1A in the periodic table, so its oxidation number equal positive 1. Positive 1 plus X, which is Cl, equals 0, so Cl will be equal negative 1. In this way, we can calculate oxidation number of any atom in any compound, okay. We have peroxides, superoxides with fluorine of oxygen, and we can calculate it by the same way, okay. And we have oxidation reduction reactions, okay. We called it about it redox, okay, redox, which is reduction and oxidation, okay. About oxidation, okay, in easy way, if the oxidation number increases, so it's oxidation process, and the Na, like Na, it's equal 0 and change it into positive, so the oxidation number from 0 to positive 1, so it's increased. By increasing it, so we conclude that oxidation process, and sodium in this case will be reducing agent. So oxidation process take place in 2 reducing agent, and reduction process take place to oxidizing agent. Reduction process, it's if the number of oxidation will be decreased. We have positive 2 in this atom, and the other hand we have Cu and change it into Cu0 from positive 2 to 0, so it's decreased. By decreasing it, we conclude that it's reduction process, and Cu in this case will be oxidizing agent, okay. We have example Zn, okay. We have atomic groups. Is very important. Atomic groups, okay. Ammonium group, they are a set of elements and take the charge in it, okay. The charge in it equal oxidation number of them, okay. We have ammonium group in H4, and it has positive 1, and OH negative, nitrate in O3 negative 1, CO3 negative 2, so it's must be kept very clear, okay. So in this example, Zn change it into ZnSO4, so it's in atomic state, so it equals 0. And on the other hand, Zn on the other side, Zn it's positive 2. Okay, why? Because all of this compound equals 0, so SO4 equal negative 2 from the table. That's clear. And SO4 equal negative 2, so X, which is Zn, okay, Zn plus negative 2 equal 0, so Zn will be positive 2. So from 0 to positive 2 it increases, so it's oxidation for Zn, okay, about Cu, and Zn in this case it's reducing agent, but Cu it's equal positive 2 by the same way we calculated, and change it into 0 from positive 2 until 0 it decrease, so it's reduction process. Okay, and now we end our revision, and thank you for